Beyond the inner one moves. Beyond the inner worlds, the giants, the solar system changes as one moves past the rocky inner planet's close orbit, which includes Mercury, Venus, Earth, and Mars, as well as the asteroid belt's drifting debris. Jupiter and Saturn are the real giants that rule over these frigid outer regions. These enormous worlds, which dominate space due to their astounding size and gravitational pull, are vast spheres of swirling gas rather than solid like Earth. Like a celestial monarch, Jupiter, the largest planet in the solar system, rules over its surroundings. Encircled by its bright rings, Saturn follows with equal grandeur, a graceful demonstration of cosmic artistry. Here, however, violence is concealed by beauty. Giant storms that dwarf entire planets swirl through their atmospheres. For centuries, Jupiter's great red spot, a storm bigger than Earth, has been raging across thick clouds of helium and hydrogen. Lightning flashes. At unthinkable speeds, winds roar. These are tumultuous places of pressure and mayhem, not calm skies. Massive magnetic fields are another unseen force that exists beyond their storms. Jupiter's magnetosphere is so strong that it creates an imperceptible shield that would destroy the majority of spacecraft by trapping radiation at lethal levels. Scientists are still trying to figure out how Saturn's exceptionally powerful magnetic domain shapes the surrounding space. Then there are their moons. These giants are surrounded by dozens of icy, rocky, and enigmatic worlds. Under its frozen surface, Europa conceals a global ocean. Water vapor plumes are sprayed into space by Enceladus. Titan has lakes and rivers, but they are made of methane rather than water. Our knowledge of habitability is called into question by these moons, which also pose the important question of whether life could exist so far from the Sunday. It is no easy task to reach these far-off Titans. Missions take years, not months. Extreme gravitational pulls, crushing radiation, and the vast void between worlds are all things that spacecraft must endure. Every journey requires exceptional engineering, precision, and resilience. But we still go out there in spite of the risks and the distance, because the solar system's giants and some of its biggest mysteries are located in the regions of Jupiter and Saturn, which are outside the asteroid belt. The Grand Tour era, human ambition had finally overtaken technological capability. By the early 1970s, spacecraft had evolved into seasoned explorers rather than brittle experimenters skimming close to Earth. Engineers created devices that could endure years of darkness, the intense freeze of interplanetary space, and unrelenting particle radiation. The outer solar system was within reach for the first time. The ensuing events signaled the start of humanity's first actual interactions with the giants. This chapter chronicles those groundbreaking expeditions, the probes that pierced the abyss to unveil Saturn's dazzling rings, Jupiter's storm-scarred face, and the shocking prospect of oceans hidden beneath frozen crusts. With more than twice the total mass of all the other planets, Jupiter is the largest planet in terms of mass. Its enormous globe, which is 11 times wider than Earth, is encircled by tumultuous bands of hydrocarbon haze and ammonia clouds. Its surface is constantly roiled by storm systems that collide and reform in an unending dance of mayhem. Despite being lighter, Saturn attracts attention with grace rather than strength. Encircled by rings of stone and ice that stretch farther than 24 Earths arranged, side by side, it is shrouded in a golden haze. These glistening, delicate, yet enormous arcs have grown to be among the solar system's most recognizable sights. Both worlds rule over sprawling families of moons. Some are barren and scarred, others pulse with geologic energy. Volcanoes erupting in frozen darkness, oceans hidden beneath miles of ice. In these distant orbits, scientists began to glimpse environments that might challenge long-held assumptions about where life can exist. Yet distance remained the greatest obstacle. Jupiter circles the Sunday at now 5 times Earth's one of distance. The most promising habitats. Saturn lies nearly twice as far again. By 2003, sending a spacecraft across such expanses rather than risk contaminating durability potential, it demanded brilliance with terrestrial. In 1964, scientists NASA commanded Galileo to dive into Jupiter's atmosphere. A rare celestial spacecraft disintegrated in a final every 177 its destruction, the outer planets arranged themselves in a configuration its end marked that allows a spacecraft to use their gravity had already begun. Stones. Cassini, Huygens, harnessing each planet's pull just weeks after Galileo's final descent, a probe could accelerate. Explorer arrived at Saturn. Additional fuel. Cassini, Huygens wanting from one giant to the next. NASA, the European Space Agency, something extraordinary. And the Italian Space Agency working together. Outer solar system Galileo completed. Cassini carries not an atmospheric without this alignment. Such a journey would have taken far longer. The giant moon, perhaps longer than a single scientific generation. The window was brief. The opportunity was historic. Humanity chose to take it. The pioneers, humanity's first scouts to the giants, before committing to the ambitious grand tour of the outer planets. NASA chose caution. The agency would first send 2 pathfinders, rugged scouts designed to test the journey ahead. Their names were Pioneer 10 and Pioneer 11. Launched in 1972 and 1973, the twin probes were built to endure what no spacecraft had faced before. They spun steadily for stability and carried instruments to measure magnetic fields, radiation, interplanetary dust, and light across multiple wavelengths. Their mission was simple in concept, but daring in execution. Survive the passage to Jupiter and report back. Pioneer 10 led the way. It became the first spacecraft to cross the asteroid belt without catastrophe, easing long-held fears of constant collisions. In late 1973, it approached Jupiter, a world never before seen up close. The images it returned transformed planetary science. Swirling cloud bands filled the frame. The great red spot loomed in turbulent detail. For the first time, humanity witnessed the giant not as a distant blur of light, but as a dynamic, violent world. But Jupiter did not welcome its visitor gently. The planet's intense radiation belts unleashed a storm of high-energy electrons that battered the probe's electronics. Systems faltered. Nearly half its instruments were disabled before the moons could be fully studied. Yet Pioneer 10 endured. On the 3rd of December, 1973, it completed its historic flyby. Then gravity took hold. Jupiter's immense pull seized the spacecraft and accelerated it to escape velocity, flinging it outward and away from the Sunday. In that moment, Pioneer 10 became the first human-made object set on a trajectory toward interstellar space. A year later, Pioneer 11 followed. It ventured even closer to Jupiter's cloud tops and, remarkably, emerged with its instruments largely intact. Its sharper images revealed the planet's polar regions, territory never before observed. But Pioneer 11's mission did not end there. Instead of using Jupiter as an exit ramp, the spacecraft used the giant's gravity as a slingshot. Redirected onto a new path, it arced outward for 5 years through the dark expanse between planets. In 1979, it reached Saturn. There, Pioneer 11 performed a bold maneuver, diving between Saturn and its rings. The passage proved that such a route was navigable, clearing the way for the Voyager missions that would follow. Emerging safely, the probe received one final gravitational boost and joined its sibling on an endless outward journey. Today, both Pioneers drift more than 100 astronomical units from the Sunday. Their instruments are silent, their systems are cold, yet they are not forgotten. Bolted to each spacecraft is a small gold, anodized black, a message in universal symbols. It depicts a man and woman, the relative position of our planets, and a pulsar map designed to guide any discoverer back to Earth. Conceived by a team led by Carl Sagan, the plaque was humanity's first deliberate attempt to introduce itself to the cosmos. These messages may never be read. The probes may wander for millions of years without encounter. Still, they endure. Our first physical signatures cast into the vast dark ocean of the galaxy. Galileo, staying to understand flybys, had delivered revelations, but they were brief encounters, cosmic drive-bys that offered only snapshots of immense worlds. To truly understand the gas giants, scientists needed more than a passing glance. They needed time. They needed orbiters. An orbiter could remain in place, circle its target repeatedly, and watch as storms evolved and seasons shifted. It could return to the same moon again and again, tracing surface changes and probing beneath icy crusts. It could transform isolated discoveries into sustained investigation. That ambition took shape in a mission named Galileo. Designed as a two-part spacecraft, Galileo paired an orbiter with an atmospheric entry probe. The plan was bold. While the main craft would circle Jupiter and study its moons over years, a smaller probe would plunge directly into the planet's atmosphere, sampling its composition, temperature, and structure as it descended into the crushing depths. The mission was conceived in the 1970s, at a time when outer planet exploration was accelerating. But Galileo's path to launch was long and difficult. Technical challenges, shifting budgets, and delays reshaped its timeline. Then, in 1986, the Space Shuttle Challenger disaster brought shuttle launches to a halt, forcing further postponements and redesigns. At last, in 1989, Galileo lifted off aboard the Space Shuttle Atlantis. Its journey to Jupiter was anything but direct. Lacking the power of a massive launch vehicle, the spacecraft relied on gravity assists, swinging past Venus and twice past Earth to steal momentum from their motion. With each pass, it gained speed without burning extra fuel, gradually building enough energy to reach the outer solar system. 6 years after launch, in 1995, Galileo finally arrived at Jupiter. For the first time, humanity would not merely visit the giant, it would stay, fire into the clouds on the 7th of December, 1995. Galileo's atmospheric probe met its fate. It struck Jupiter's upper atmosphere at 180,000 kilometers per h-hour, a controlled plunge into chaos. For 58 extraordinary minutes, It endured parachutes deployed, instruments activated, data streamed home. It measured supersonic winds, rising temperatures, and the chemical composition of alien skies. Pressure mounted, heat intensified, then silence, crushed and melted by conditions no machine could long withstand. The probe vanished into Jupiter's depths. Yet in less than an hour, it had rewritten textbooks. The following day, the orbiter fired its main engine and slipped into orbit around Jupiter. The first spacecraft ever captured by an outer planet. What followed was 8 years of revolution. Across 35 looping orbits, Galileo transformed our understanding of the Jovian system. It watched volcanoes erupt on Io, painting the moon's surface in sulfurous yellows and reds. It confirmed that Ganymede generates its own magnetic field, the only moon known to do so. And on Europa, Galileo detected compelling evidence of a vast saltwater ocean hidden beneath kilometers of ice, a dark global sea, now considered one of the most promising habitats for life beyond Earth. By 2003, its fuel was nearly gone. Rather than risk contaminating Europa's potential ocean with terrestrial microbes, NASA commanded Galileo to dive into Jupiter's atmosphere. The spacecraft disintegrated in a final blaze, its destruction an act of planetary protection. Its end marked the close of one era. Another had already begun. Cassini-Huygens Saturn Sentinel. Just weeks after Galileo's final descent, a new explorer arrived at Saturn. Cassini-Huygens was an international mission. NASA, the European Space Agency, and the Italian Space Agency working together. Unlike Galileo, Cassini carried not an atmospheric probe for Saturn, but a lander destined for Titan, the giant moon cloaked in orange haze. After a 7-year journey, using gravity assists from Venus, Earth, and Jupiter, Cassini entered Saturn's orbit in July 2004. On Christmas Day that year, the Huygens lander separated. 3 weeks later, it descended through Titan's thick atmosphere. On the 14th of January 2005, Huygens touched down on a frozen plain strewn with icy cobbles, the only landing ever achieved in the outer solar system. What it revealed was astonishing. Titan possesses river channels, shorelines, and vast lakes. But they are not filled with water. Instead, methane and ethane flow across its surface, forming a cycle eerily similar to Earth's hydrologic rhythm. Titan breathes in hydrocarbons, rain falls, rivers calve, seas gather. It is a frigid, organic, rich world, one that may resemble the chemistry of early Earth. 13 years at Saturn, Cassini remained in orbit for 13 years, becoming Saturn's constant companion. It discovered geysers erupting from Enceladus, plumes of water vapor and ice grains blasting from a subsurface ocean rich in salts and organic molecules. It mapped the intricate structure of Saturn's rings, revealing moonlets, sculpting waves and gaps. It observed a vast hexagonal storm circling Saturn's north pole and witnessed the rare eruption of a planet-wide great white spot. Cassini's data formed the foundation of thousands of scientific papers. It reshaped our understanding of giant planets and their moons. As its fuel dwindled in 2017, mission planners chose a daring finale. The grand finale in its final months, Cassini executed 22 dives between Saturn and its innermost rings, a region never before explored. It sampled ring particles directly. It measured the planet's gravity and magnetic fields with unprecedented precision. it skimmed the upper atmosphere, gathering final data. On the 15th of September 2017, Cassini plunged into Saturn's clouds, traveling at over 120,000 kilometers per hour. It fired its thrusters to keep its antenna pointed toward Earth. For moments, it transmitted atmospheric measurements in real time. Then the spacecraft tumbled. Signal was lost. Minutes later, Cassini burned apart. Its destruction ensured that Titan and Enceladus, both potentially habitable, would remain uncontaminated. Even in death, the mission protected the worlds it had revealed. The next chapter, exploration, did not end there. Today, NASA's Juno spacecraft orbits Jupiter, probing its deep interior and polar cyclones. ESA's JUICE mission is en route to study Ganymede, Europa, and NASA's Europa Clipper will soon scrutinize Europa's hidden ocean. And in the 2030s, Dragonfly, a nuclear-powered rotorcraft, will fly through Titan's thick skies, sampling dunes and impact basins for chemical clues to life's origins. The gas giants are no longer merely destinations. They are gateways to oceans beneath ice, to alien chemistry, to environments where life might endure in darkness. Beyond them, the Voyager spacecraft continue outward, carrying golden records filled with Earth sights and sounds. They have crossed into interstellar space, still whispering data home as they sail the galactic deep. Exploration does not end, it expands. Each mission pushes farther into deeper mystery, wider distance, and greater understanding.